And it's not what my wife wants, I find a different wife.
Sometimes it's too late.
She's taking the dog's and the money.
Well, if we're getting married.
Beggars can't be choosers. Alright. So we're starting, starting probability. The stuff we just did, which you guys did pretty well on the test. We're not in power school yet, sorry about that. I have to do them at this time. What? Yeah. I took Thanksgiving break also. And I meant to get done before we left, I just didn't know that. So that's like 10 to 15% of the AP test. Probability is another 10 to 15% of the AP test. So this chapter, and then the next one is also probability. There's another chunk that's on the test. So this is a unit. This is actually a unit that a lot of people struggle with. Like I look back through my old folders. It's totally bad. So it's the opposite of the last chapter where there was like no one. Looking back through, and just about every year I have like review number 2, review number 3, extra practice problems, retake number 1, retake number, like I have all this stuff because people needed more help or extra retakes or whatever. So I know, getting close to Christmas, I guess it's easy to, I'm trying to remember like in high school when my brain like just stops caring as much, but I wouldn't do that now. That was first day of school. So I wouldn't like make this the chapter you decide to slack off on. That's kind of what I'm getting at, because I think.
Well, the last chapter.
So if I don't say this before the chapter, that means it's not a super hard chapter. I didn't say it before last chapter.
Yeah, last chapter was.
This is a pretty tough chapter.
Last chapter you said you didn't.
Last chapter you could have slacked off, but you didn't.
Right. I just didn't tell you.
Too late.
Right. Now you're good. So, it's third hour. Okay. So we got a few little definitions up here. And so you're going to start to think it's like not math, but then we start doing problems. It does. There is math. It's like all math, logic, like it's actually a math class. Yeah. So probability, you do want to know the definition here. The key phrase here that you want to understand is long run. So, let me ask you this. What's the probability if I flip a coin, I get 50%? How do you know that?
2 odds, 1 is
Like, I take out a coin right now and I say, what's the probability this comes up heads? You can't land on sides. It's got to land on one side or the other.
Actually, nickel has a 1 in 5,000 chance of landing on. You didn't care.
Wow.
Sorry.
That's fine.
Their thing is
Not what I'm interested in right now. You flip a coin. What's the probability it lands heads? I just gave you a coin out of my pocket. How do you know?
1 out of 2.
How do you know?
Because there's 2 sides.
What if it's weighted? What if one side's heavier?
It's not. Then it's not a real coin. Yeah, how can you
the 50-70 is actually.
Is it 50 heavier on one side? Alright, now that information I want. How many times would you have to, if you flip it twice, you get 1 and 1. Are you convinced? You flip it 10 times, 5 and 5, are you convinced? 1,000? Say it comes out 502 and 498.
Yeah.
Well, why isn't it 50.2% and 49.8%? So how many times would you have to flip it to convince yourself? Like, if I say theoretically it's 50%, how many times would you have to flip it to convince yourself that it might be different than 50%? Like, the point I'm trying to make here is the only way you really know is to do it like a billion times. Like, the long run is the really, 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 really long run. So some people say they're good guessers on tests, right? Like, oh, that's fine, I'm a good guesser. Which, first of all, bullcrap, no, you're not. Nobody is. But say you got a 100-question true-false test. You get 60 right. Are you convinced you're a good guesser? Like, you're just blindly guessing.
Yeah.
Yeah? 60 convinces you? Out of 100?
I mean, okay guesser. A, B, C, D.
True or false?
Oh, no.
1,000 true false, and you get 550 correct. Would you be convinced you're a good guesser?
No.
So
I mean,
what I'm getting at is the long run is a really long time. So you can't look at something that happened 50 times and be like, oh yeah, I can tell that's right. That's the main thing I wanted to get. One means it's going to happen for sure. This is like a notation thing. So the way you would read this is the probability that Tuesday comes after Monday is 1. Please stop talking. 0 means it never happens. So this is the probability that it snows 190 degrees is 0. And 0.5 means it occurs half the time. Again, over the long run. So the long run is the key. So if you are asked to provide a definition or find the definition of the AP test, it better have long run in there. So, right. Random means unpredictable in the short term, but predictable in the long run. So random doesn't mean there's no pattern or no like predictability to it. It just means I don't know what's going to happen like the next time or the next 10 times. Like a coin flip is random, right? I don't know what's going to happen on the next flip. I don't know what's going to happen on the next 100 flips. But I know if I flip it a million times, it should be pretty darn close to 50% of them are heads and tails. It's another definition that you should memorize, you should know, you should be able to identify the AP test, online test, whatever. I don't know what's going to happen in the short term. I am able to predict what's going to happen in the long term. So if you start taking a million question true false test, I don't know what you're going to get in the first 10 questions. But I'm pretty sure after a million questions, you're going to be right around 50%. So it's random in the short term, but in the long run, it's predictable. Sample space, they can trick you up with just the way they word this. This is all the possible outcomes. So, but the way they phrase it can trick you. What is the sample space for the number of heads that I get if I flip 3 coins? So if I say, you flip 3 coins and I say, how many heads did you get? What are your possible answers? 0, 1, 2, 3, right? You put them in those little fancy braces. You're not good at making those. So, the second question is different though. This is like you flip 2 coins and I say, hey, what was your outcome? What'd you get? So your answer can't be 0. Like if I say, hey, what'd you get? You can't say 1. Like that doesn't make any sense. So your possible outcomes would be heads, 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 tails, tails, heads, or tails, tails. So it's just like a subtle wording of the question that can change what your response is supposed to be. And that's not like a big thing usually. I don't see it maybe just very often, but it can come up. It's annoying. It's just like a wording trick. Okay, this is what we're going to work on today mostly. We're going to make a probability model. So let's say I have a coin that lands 60% heads 60% of the time. I'm going to make a tree diagram. You guys seen those or do you remember from the summer work? Where it starts like this, then you got it breaks down again, and you could have another level there if you want. Those look familiar-ish. I'm not gonna go through them, but alright. So if I have a coin that lands 60% of the time, we're gonna flip it twice. I didn't really write that in the notes here, but we're gonna flip it twice. I want to make a tree diagram. You guys with me? And then a probability table. So the tree diagram starts here, and your first flip, I could get heads, I could get tails. 60% of the time I get heads, 40% of the time I get tails. And then no matter what happens, I'm going to flip again. So I'm doing another branch off from there. And on that flip, I'll get heads 60% of the time, tails 40% of the time. Heads 60% of the time, tails 40% of the time. I'm only flipping it twice, but if I wanted to do it 3 times, I just didn't leave enough space, but then I would do another branch off of all 4 of those. So I can start kind of telling some things already. How many possible outcomes are there? 4, right? So you got 1 here. You just follow the branches. So then what you do is the probability of heads, heads. You follow that path. And we haven't learned the formula, but if it's and that you're looking for, like I need heads and means multiply. Or means add. Let's write that like on the side somewhere. And means multiply, or means add. That's a very general tip that you can use if you get stuck. So if I need heads and heads, I'm going to multiply 0.6 times 0.6. And that would be 0.36. So again, just the notation. This says the probability of heads and heads equal, so that's what that P means. So the probability of heads tails would be 1 times 1. 0.6 times 0.4. 0.24. Probability of tails heads. 0.4 times 0.6. And then the probability of tails and tails, again, and means multiply. 0.4 times 0.4. What should all of those add up to? Should add up to 1 because you have to get this or this or this or this, or means and, or means add. Or means add. So if you add all those up, you have to get one or the other or the other. So you should get one when you're done. And then I can look at I can kind of ask you some other questions now. What's the probability that I get tails at least once? Take a second to answer that question. What's the probability that I get tails at least once? Don't say it out loud. And try to tell me 2 ways to get to that answer. What's the answer? 0.64. How'd you get to it? Okay. So tails at least once means I need this or this or this to happen, right? What's or mean? Add. So I'm just adding those 3 up. The other way to get to it, everybody think about it differently? Yeah. Right. Yep. So you know these have to add to 1, right? If I take away the only one that doesn't have a tails in it, right, just do 1 minus that, you'll get the exact same answer. What's the probability that both flips are the same? Because a lot of these are like boy-girl. Like you can do the same type of question with boy-girl. What's the probability both flips are the same? 0.52, right? Because you need this or this, and you're adding them up. Here's the tough card. If you know you have at least 1 head. So given that you have at least 1 head, what's the probability that you have a tail? This is hard. We'll spend a lot more time on this. But given that you have at least 1 head, what's the probability that you have a tail? Not a lot. I don't know if it's right or not, just not a lot. A second. So given that you have at least 1 head, what's the probability you have at least 1 tail? Right at the end. Don't want an answer yet. So what we're doing is eliminating part of the game. If I say I need at least 1 head, the tails is no longer even in the discussion, right? So now your total possibilities don't add up to 1 anymore. What do they add up to? They add up to 0.84. As I said, you know that you have at least 1 head. So this one's just eliminated. So if I have at least 1 head, I must have gotten this or this or this. Again, what does or mean? Means add, so this comes out to 0.84. Out of those, which ones have tails at least once? These two, so 0.48 divided by 0.84 would be, and we're going to spend a lot more time on this. I'm not trying to really teach this right now, I'm just trying to expose you to it a little bit. How many had that as an answer in your brain or whatever? Okay. Well, that's tough. That's a tough one. We'll do a lot more with that one. Alright, let's go down to the probability table. So I'm going to go down here and I'm going to say X equals number of, I'm going to do heads, you can do heads or tails, but this is like your title. And then then we put x here and the probability of x down there. Test your vocabulary here. What's the sample space for number of heads? I've got like crusty stuff on my table. What's the sample space for number of heads? 0, 1, and 2. That's just the number. That's just the possible outcomes. So I could have 0 heads. I could have 1. I could have 2. And I'm going to just fill in this table. So what's the probability I have 0 heads? Well, if I have 0 heads, I must have gotten tails, right? So that's 0.16. If I got heads once, I got heads, tails, or tails, heads. Again, what does or mean? It means add them up, so that's 0.48. And then if I got heads twice, that's got to be 0.36. Again, what should these add? Should have 1. Questions on that one? Let's do one with 3. So there's a ton of room on this next page. There's going to be 2 problems. I'm going to do this one up here with you. So don't use up your whole page. Then I'm going to give you one to do like on the bottom. So I'm going to start this one with you. So now we're doing, I get heads 70% of the time. And I'm flipping a coin 3 times. Quiet, please. So I'm adding a layer to it, and I change the probability. Some people do the trees down too, which actually makes more sense. Actually, it looks like a tree then, I guess. Well, upside down tree. But some people do it this way, and then you're doing heads, tails, and that's totally fine. Like that's not right or wrong. It's just a preference. So I'm flipping the first one. Spread your branches out because you're going to need a lot of room here. HT. So remember heads is 0.7 now. Tails is 0.3. And then leave space down here. You might need like a separate sheet for all this. We're going to do the best we can. So up here I'm going to flip it again. I'm going to flip each of those again. Try to squeeze this in. Down here you're flipping again. And then you're flipping each of those again. And every time you see an H, what's the probability? 7. Every time you see a T, 0.3. And I can change the game halfway through too. I'm not doing that yet, but like I could say, okay, first you're going to flip a coin that's 70% heads. Then you're going to flip a coin that's 30% heads. Then you're going to flip a coin that's 50% heads. And then kind of make you work through each one of those separately. It's not like that much harder, but we're not quite there yet. And then the same idea. This isn't any different than the last one, just more layers. So this, if I follow that very top branch along, HHH, so you need H and H and H. What does and mean? Multiply. So that's 0.7 to the third, basically, right? And you can write out 0.7, 0.7, 0.7 if you want. And this would be the next one down. Will be what? What are the flips there? HHT. 0.7, 0.3. You guys see what I'm doing? Questions on what I'm doing? Alright, keep going, finish it. good thing to check at the end. It would be what your eligibility probabilities. How could you add them all up? And what did you get? You won. And then at the bottom, or wherever you have room, I want the probability table too. Don't forget to label it. There's going to be a bunch of formulas and stuff in this chapter, but a lot of the problems we do, even though this would take longer, will get you where you need to go. So if you can do this, I don't think it's too difficult, but if you can get this down, you can rely on this a lot later on if you get stuck. Don't write down my snow days. Change plans. What are some other questions? So then I want the E, F, and G, or what I was trying to refer to a minute ago, like that tougher one I gave you. And I don't even explain the notation yet, so if you're trying those, you're probably going to be you have trouble, so just wait for me if you want. A, B, and C, A, B, C, and D, though, which is try. And these are the kind of questions you can answer without the table, but the table makes your life a lot easier. Should I have the table up still, too, for the answers? I'm trying to show, like, everything. Is that big enough? You can see all that? Like in the back here? Just like,
No, like you could have heard it.
Yeah. Yeah. Are we good on the top? Like, does everybody have these numbers the same as I do? You guys got the table the same as I do? Question on that part? Okay. So then what I'm asking down here, so X, I'm looking at this chart. So X is the number of heads. What's the probability I got more than 2 heads? Well, what's the only way I can get more than 2 heads? I need to get 3, so this would be 0.343, right? Are you guys done with these, or should I wait a second? I can wait. Good. You guys remember this notation? This means like X is between 1 and 3. It's got the or equals 2, so it could be 1, 2, or 3 then. I'm trying to teach here. Keep it down. Bless you. Dylan, what's the probability X is less than or equal to 2?
It's 0.657.
How'd you get it?
Well, the only one that doesn't have less than or equal to 2 is 3. So I just did 1 minus 0.343.
So he decided instead of adding up 0, 1, and 2, I'm going to take 1 and just get rid of those. How else did you do it? Just add up the 0, 1, and 2. You're getting the same thing either way. You're either adding up what is there, or what you do want, or you're subtracting out what you don't want. So we'll talk about that a lot as the chapters go on. You can either add up what you want or subtract what you don't. And you kind of look at which one's easier, which one's less work for you. We did 1 to 3. So it's the same thing. I could add those up, or I could subtract that one. So what's that? 0.973. Probably X equals 0. I'm not even sure why I put that on there. That's just, hopefully you can return it. Questions on those? Alright, so E, F, and G. This is the hardest thing for people in this chapter, and there's a formula for it later. And I'll show the charts thing later. But I'm going to just show it day 1 this year, and just kind of try to hammer it out like throughout the chapter, because this is the hardest concept for most people. So if you're not getting it, don't freak out. There's a lot more to go. But I'm just trying to kind of fix what I do to see if I can make people understand it better. So remember, probability in general is like the success over the total options, right? So why is it flipping a coin 1 out of 2? Probability of getting what you want is 1. There's 2 options. Fair enough? Pleasure. So what we're doing here, so this bar means given. So anything after that bar, we're saying we know that's true. So if I'm looking at this first one, I'm saying I know X is greater than or equal to 1. So as soon as I know X is greater than or equal to 1, that is not even in the game anymore. So now I'm only looking at the 1, the 2, and the 3. Because I said I know for a fact, like I caught a sneak peek at the die or something, and I could tell. I mean, I don't know how this works, but like I just know that it's greater than 1. So that eliminates this. So now, what's the total probability of your options? 0.973. It's not 1 anymore because we took away that the 0 is a possible option. Right? And the top is made different. What's the probability that X equals 1? 0.189. 0.063 would be like, there's 3 ways that could happen though, so you multiply it out. So, should a 1 be more likely or less likely if I eliminated one of the possible options? It should be more likely, right? Because I took some of the game away. So the 1 has the same probability, but there's less total options. So if you divide this out, should your answer be bigger or smaller than 0.189? It should be bigger. Go ahead and divide it. I mean, you can tell by just the division too. But so now, if I take that 0 out of the game, my odds of getting a 1 go up just a little bit. This is card counting. People that go to the card count cards at blackjack, given that I saw all these cards go away, that changes the odds going forward. And that's how you guys seen like 21.
That's a great.
It's cool. Well, so it's not illegal, but if they catch you doing it, they kick you out.
Yeah.
I've never done it.
They can also like messing up a little bit.
Yeah, I don't know if that's really legal, but not the topic I want to discuss. The point is, as you gain information, the odds change. And that's what this is. This is the information that we now know. Now what's the odds? So the odds of getting a 2 before were 0.441. If I know x is greater than or equal to 2, now what's the odds of getting a 2? So try F and G. I know I've only explained 1, but see what you can do with F and G at this point. I told her to be quiet when she said it. He knows I told people that wouldn't come as a surprise. You didn't say anything about what maybe that was the reason.
I actually thought of one thing that I saw in there, like, yeah, I probably should. I don't even remember what it was now, but
Like, he wouldn't judge me on how you behave, he would judge me on how I respond to your behavior.
yeah, I know.
But you might not
But I didn't want to put you in that position.
I
Like,
appreciate it. I would've been big.
oh, now I remember. You missed a 0.3 in your tree. At the bottom. That's what I was going to tell you. I remember now. And I could see you making some kind of comment.
You're right. That's not like a grammar thing. That's like a mathematical. Alright, so let me go through these two. Again, these are tough. Like, I'm not expecting, perfection at this point, right? So F says, if I know that x is greater than or equal to 2. So what we're doing there is reducing our options. So I know the only options that are in this game anymore are the 2 and the 3. Because I'm telling you, I know for sure x is greater than or equal to 2. So if I add those up, what do I get? 0.784. So your options now are 0.784. You don't have all of them. You don't have a 1 anymore. You just have 0.784. Probability of x equals 2 is still 0.441. It's just now we have less options. So like if the game is only the 2s and the 3s, isn't the 2 like more likely than not to be the one that gets taken? Whereas before it was less than 50%. But if I eliminate those, it's more. So as you change the information, the game changes. And I didn't divide those yet. But. So 0.5625. How many had that? Sure. Nice. How did you hide it?
I had the top one.
Oh. Alright, so same thing on the bottom. Anything after the bar is a fact. So it's given to you. We know that's true. So I know x is less than or equal to 2. So this 3 is no longer an option. Because I'm telling you that for sure x is less than or equal to 2. So if I take that out, what's the total probability of all my options now? 0.657. And x is greater than 1. So what's the total of those probabilities where x is greater than 1? And remember, 3 is not in the game anymore. So what would I do? 0.189 plus 0.441, right? What is that? 0.63 straight, okay. So if you divide those, so now we're at 0.96 basically. So doesn't that make more sense? So if I know that we're less than 2, less than or equal to 2, don't you almost have to get a 1 or a 2? Like, the odds of getting 0 are so low. You're almost for sure going to get a 1 or a 2, and that's 0.96 is like almost for sure. That's not how the lottery works. How many have 0.96? How many? Okay. Is it really only 3 people out, or you're not listening? How many have 0.96? Okay. Try one more after I have. So maybe this helps. Try the probability x equals 3 given that x is greater than 1. So I'm up here now. So your rough day is continuing. Okay, let me go through it. Quiet, please. So on the bottom, you're putting just the total probability of all of your options, which is usually 1. But now I'm eliminating things, so it's not 1 anymore. I know x is greater than 1, which means it has to be 2 or 3, right? It's greater than 1. So those aren't in the game anymore. If I add those up, that's the 0.784 number, right? So now, just in general, so what's the probability x equals 3? 0.343, what do I get if I divide those? How many got 0.4375? Nice. Are you getting it? Like you're getting there? Alright. I'll give you basically this problem again.